So this lesson is going to go over how to do rational functions. It is something that we talked about in Algebra 2. I'm going to spend today reteaching 3 different things. We're going to review the 2 parent functions, y equals 1 over x and y equals 1 over x squared. We're going to review how to graph them using transformations. The next thing we're going to review is how to find the domain given just an equation and not a graph. How to find the horizontal and vertical asymptotes given an equation and not a graph. Okay, so the first thing we want to do is we want to go over the 2 parent functions for rationals. We have our 1 over x function and we have our y equals 1 over x squared. When you're graphing the y equals 1 over x, the first thing you're going to have to remember is that it has 2 asymptotes. So we're going to have a horizontal asymptote right here at the x-axis at y equals 0. And we're going to have a vertical asymptote right here at the y-axis. After you graph your horizontal and your vertical asymptote, when you're graphing y equals 1 over x, from the middle, from the origin, we go right 1, up 1, and we put a point, and we draw the right half of my function. It's going to approach the asymptote from the left and from the bottom. We're going to go back to the middle, and we're going to go left 1, down 1, and it's going to follow the same thing. It's going to approach the asymptote at the top and at the right. And this is our graph of y equals 1 over x. Y equals 1 over x squared is very similar. It's going to have the exact same asymptotes. It's going to have a horizontal asymptote at y equals 0, the x-axis, and a vertical asymptote at x equals 0, which is the y-axis. For y equals 1 over x squared, from the middle, we're going to go right 1, up 1, just like we did over here. And we're going to approach the asymptotes from the left and from the bottom. The difference between the 1 over x and the 1 over x squared is I am going to go left 1, up 1. I always say that this one kind of looks like a volcano. So when you're graphing 1 over x and 1 over x squared, the first thing you're always going to do is you're going to graph your vertical and your horizontal asymptotes. Then you're going to graph 2 points. If it's a 1 over x, you're going to have one on the right side and one on the left side at the bottom. If it's a 1 over x squared, they're both either going to be on the top or both going to be on the bottom. The only way they're both going to be on the bottom is if this is a negative. The only way these 2 arms would flip is also if it were a negative. Okay, so let's go do some practice problems. So if they ask me to graph y equals 1 over x squared plus 1, the first thing I'm going to notice is this is an x squared problem. So if you were to graph the parent function, it would look like this. We just went over this. This is what the 1 over x squared looks like. Okay. But instead of graphing 1 over x squared, they want me to graph 1 over x minus 2 squared plus 1. So we're going to use our transformation rules to graph this. The first thing I'm going to notice is because it says a minus 2 inside, that means that my graph is going to go right 2. Because there's a plus 1 on the outside, my graph is going to go up 1. So when graphing rationals using transformations, always shift your asymptotes first. So my vertical asymptote is going to go right 2. And my horizontal asymptote is going to go up 1. So my asymptotes that were on the axis have now shifted to be at x equals 2 and y equals 1. From there, I'm going to follow the pattern that I did for the parent function. I'm going to go to the middle, which is right there, and I'm going to go right 1, up 1, and approach the asymptote from both sides. And then I'll go back to the middle, and I'm going to go left 1, up 1. Again, it still makes that volcano shape, but you can tell that it was at 0, 0, and now we've moved right 1 and up 1. Okay, let's practice another one. For this particular graph, it says negative 1 over x plus 3 minus 4. Notice there's no squared on this problem, so this is going to resemble the parent function y equals 1 over x. So again, the asymptotes are at the exact same spot. 1 over x, we go right 1, up 1. And we go from the middle, left 1, down 1. So I'm going to take this parent function and I'm going to create a transformation. This plus 3 at the bottom is going to make my graph go left 3. This minus 4 is going to cause my graph to go down 4. And this negative on the top is going to cause these 2 arms to reflect. So instead of the right side being on the top, the right side's going to be on the bottom. Instead of the left side being on the bottom, it's going to end up going to the top. So again, just like in the first example, you graph the asymptotes first. We're going to go left 3, and we're going to go down 4. Okay. From there, we're going to go to our middle point, and normally I would go right 1, up 1. But because there's a negative, I'm going to go right 1 and down 1. So the right side's at the bottom of the graph this time. I go back to the center, and normally I would go left 1, down 1, but now I'm going to go left 1, up 1. And there you go. So we did a 1 over x squared, and we did a 1 over x. Let's do one more where we have to do some factoring. So on this particular problem, I have 1 over x squared plus 8x plus 16. So we know it's most likely going to be an x squared problem. But in order for it to look like a graphing form of an x squared, I need to go ahead and factor the bottom. So when I factor the bottom, we get 1 over, I'm looking for factors of 16 that add up to 8. Well, that would be x plus 4 and x plus 4, which would be the same as x plus 4 squared. So we're graphing an x plus 4 squared graph. And I can tell because there's a plus 4 that my graph is going to go left 4. There's no plus or minus out here, so it's not going to go up or down at all. It's going to stay on the x-axis. So I'm going to have a horizontal axis at 0. That one didn't change because there's no plus or minus out back. There is a plus 4 in here, which makes me go left 4. So this is my new center. It's an x squared graph, so this is where we have either both on top or both on bottom. Because it's a positive, they're going to both be on top. So I'm going to go right 1, up 1. That's the right side of the graph. Then I'm going to go left 1, up 1, and there's the left side of the graph. Okay, so now that we've talked about graphing, the next thing we're going to talk about is how do you find the domain given just an equation and not a graph. So the domain of a rational function is the set of all real numbers except for those where the denominator would equal 0. So when I'm asking you to find the domain for these rational functions, you're going to start by just looking at the denominator. And I want to know what would make that denominator equal 0. So for this first problem right here, what number could I plug in here for x that would make this bottom number equal 0? Well, if I plugged in a negative 5 right here, negative 5 plus 5 would be 0. So your domain is the set of all real numbers except, remember the word except, x cannot equal, what did we say it couldn't equal? It can't equal negative 5 because negative 5 would make the bottom number equal 0. Okay, let's go do another one. So for this one right here, I'm looking at just the bottom. What number could I plug in here for x that would make the bottom equal 0? Well, if I plugged in a negative 1 minus 1 would be negative 2, so that wouldn't work. But if I plugged in a positive 1 minus 1, that would give me 0. So this time, my domain is going to be all real numbers except x cannot equal, what did I say it couldn't equal? It can't equal positive 1. Okay, this one down here, we're going to keep going. What number could I plug in for x squared? So what number could I square so when I subtracted 4, it would equal 0? Well, 1 squared is 1, and 1 minus 4 is not 0. 2 squared is 4, and 4 minus 4 is 0. But what other number can I square and get 4? Well, I can get 2 or negative 2. So both of these numbers squared would be 4, and 4 minus 4 is 0. So this particular problem has two answers. It's all real numbers except x cannot equal plus or minus 2. All right, the last problem right down here, notice there are no x's in the denominator. And the only thing I care about is the denominator. So there's nothing down here that would make this 0. So this domain is simply all real numbers. There's nothing that could make the bottom number be 0. So when I'm asking you to find the domain, you're looking for what numbers make the denominator equal 0 And those are the answers that I cannot have. Okay, so we've done graphing and we've done domain. Now we're going to talk about how to find our vertical asymptotes by looking at an equation. There are 3 steps. The first thing you're going to do is factor if you can. After you factor, you're going to simplify to lowest terms, and then you're going to solve the denominator for x. Okay, so here we go. Got 4 examples here. Again, the first thing you're going to do is factor if you can. So there's nothing to factor on the top, there's nothing to factor on the bottom. The next thing you're going to do is simplify. I cannot cross out these 2 x's because we're adding and we're subtracting. You can only cross things out when you're doing multiplication. So I can't cross anything out, so I can't factor, I can't simplify. The last step said solve the denominator. So x minus 1 equals 0, x equals 1. I have one vertical asymptote at x equals 1. Let's go to the next one. There's nothing to factor on top, but the bottom factors to x plus 2 and x minus 2. This is a difference of 2 squares. So you take the square root of the first number, x, the square root of the last number, square root of 4 is 2, make 1 a plus and 1 a minus. So I factored, nothing simplifies. Last step is solve your denominator for x. So x plus 2 equals 0, x minus 2 equals 0. So this rational function has 2 vertical asymptotes, one at -2 and one at +2. I'm not asking you to graph it, I'm just asking you to find the asymptotes. Okay, let's go look at this third one down here. Okay, so there's nothing to factor on top. The bottom is 2 perfect squares, but there's not a difference of 2 perfect squares, so this can't be factored. Remember what I said earlier, if you have a plus sign right here, you can't go get rid of those, so this cannot be simplified. So we just go straight to the bottom, and we solve for x. So x squared equals -1. X equals the square root of -1, which is not real, so this one has no vertical asymptotes. No vertical asymptotes. Okay, the last one, there's a lot of factoring that we can do in this one. So on the top, I've got that dots thing. I have a difference of 2 perfect squares. So I have x plus 3 and x minus 3. On the bottom, I have another trinomial that can be factored. So I'm looking for factors of -21 that add up to 4. That would be x plus 7 and x minus 3. And for the first time, I can now cancel. Because we've got parentheses here, these can cancel. And all I'm left with is x plus 3 over x plus 7. And now I'm going to go solve the bottom number for x. So I have one vertical asymptote at x equals -7. Over here where these 2 canceled, that's going to create something later on that we're going to talk about called a hole in the graph. We're not going to talk about it right now, but anytime you have some factors like this that cancel, it's going to create what we call a hole. Okay, so we've done graphing, we've done domain, we've done vertical asymptotes. The last thing we're going to talk about is how to find horizontal or oblique asymptotes. Okay, a horizontal asymptote can happen in 2 different ways. The first case is our VOBO. If your exponents are bigger on the bottom, you're going to have a horizontal asymptote at y equals 0. So again, we're looking at the exponents. If your exponents are bigger on the bottom, you're going to have a horizontal asymptote at y equals 0. The second case, if your exponents are the same, you're going to divide the coefficients. It'll be a horizontal asymptote at whatever number you get when you divide. So there are 2 ways to get a horizontal asymptote. Your exponents can be bigger on the bottom, and it's y equals 0. Your exponents can be exactly the same where you divide the coefficients. If you have the bottom case, this is going to create what we call an oblique asymptote. Oblique asymptotes are diagonal lines that can either go in a positive direction or a negative direction. In order to find the oblique asymptote, you will have to do long division, and you will write it in the form of y equals mx plus b. Okay, so let's go do some examples here. All right, case number 1. So again, we're looking for horizontal or vertical asymptotes. I never said to factor, we are simply looking at the exponents. So up top I have an x to the first. On the bottom I have an x to the second. Are my exponents bigger on top, bigger on bottom, or are they the same? Well, hopefully you'll say that they're bigger on bottom. So bigger on bottom, that's a BOBO, which means it's a horizontal asymptote at y equals 0. And you're done. So I hope you get a lot of these in your homework because that's how easy it is. If your exponents are bigger on the bottom, it's horizontal at y equals 0. Okay, let's go look at our second case. We have 8x squared minus x plus 2 over 4x squared minus 1. Again, we're not having a factor. I'm just going to look at the exponents. I have a 2 here, and I have a 2 here. So are they bigger on the top, bigger on the bottom, or are they the same? Okay, exponents are the same, so this is an eats DC. Remember, DC stands for divide the coefficients. So it's a horizontal asymptote at y equals, I'm going to take these two coefficients and I'm going to divide them. What is 8 divided by 4? Well, it's 2. And you're done. Okay, so if you have a BOBO or an eats DC, they're both horizontal. BOBO is 0, eats DC, just divide those coefficients. All right, last one. 3x to the fourth minus x squared over x to the third minus x squared plus 1. So again, we're going to look at the exponents. Is it bigger on top, bigger on bottom, or are they the same? This is a bigger on top. Because it's bigger on top, this means we're going to have to go do long division. And it's also going to give me an oblique asymptote. So I know it's going to be oblique. So I can go ahead and write that part, and then I'll come over here and do my work. So when you do long division, you're going to take what's written on the bottom, x to the third minus x squared plus 1, and it goes outside the house. Inside the house goes what's on top. I like to put zeros for all the exponents that are missing. So I have 3x to the fourth, and they have a minus x squared. So 4, 2, there's a 0 x to the third missing. And then I have a minus x squared. So 4, 3, 2. So because the 3 was missing, I put a 0 there. Okay, I'm also missing a 0 x to the first, and the 1's place is 0. Okay, so I have 4, 3, 2, 1, none. Okay, from here, we're going to go do some long division. So I'm asking myself, how many times will 1 go into 3? It goes 3 times. To do the exponents, I'm trying to see how I have x to the third, but I need x to the fourth. So I need one more x. So 3x is what I have so far. And in order to get this next line down here, you have to go multiply everything up here by the 3x. So 3x times 1, x to the third is 3x to the fourth. 3x times negative x squared is negative 3x to the third. 3x times 1 is 3x. Notice there's a space right here where the x squareds were. Okay, now we have to go subtract everything. So 3x to the fourth minus 3x to the third, those are going to be 0. 0 minus a negative. Negative is going to change to a positive. So I have 3x to the third. I bring down that negative x squared. 0 minus a positive is going to give me a negative 3x. Then I have my plus 0. Okay, next you're going to look at your exponents. And as long as this exponent down here is the same or bigger, you have to keep going. So they're the same, so I have to keep going. So I'm going to do it again. How many times will 1 go into 3? It goes in 3 times. That says an x to the third. That has an x to the third, so I don't need any more x to the thirds. So now I'm just going to do the multiplication thing again. So 3 times 1x to the third is 3x to the third. 3 times negative x squared is negative 3x squared. 3 times 1 is 3. Again, notice there's a space right there. We're going to go subtract. 3x to the third minus 3x to the third is going to cancel. Negative x squared minus a negative 3 is going to be 2x squared. I'm going to bring down that minus 3x. And 0 minus 3 is negative 3. Okay, if this exponent is bigger or the same, I have to keep going. Well, 2 is actually smaller, so I can stop. This number Up top, this is your asymptote. So it's 3x plus 3. And we're not going to worry about graphing this right now. That'll come later. Okay, so what you need to do now is you need to work on worksheet 3.3. It's due Wednesday in Google Classroom. Or you can continue to work on 3.2. It's due Tuesday in Google Classroom. I hope this helped.